Okay, A2 homework this time, and we're looking at differentiation and rate of change for our homework this week. Earth is being added to a pile so that when the height of the pile is h meters, its volume is v cubic meters, where v is h to the 6 plus 16 to the half minus 4. Part 1 for 2 marks, 3 marks, find the value of dv by dh when h is 2. So we're just differentiating this dv by dh. This is chain rule. It's a function of a function. The inside function is h to the 6 plus 16, little bear, and the big function is something to the power of half. So we differentiate the big thing first, half h to the 6 plus 16 to the minus half times the derivative of the inside bit, which differentiate h to the 6 plus 16, and we get 6h to the 5. The minus 4 would differentiate to 0 as a constant. So we've got, well, we don't need to do too much tidying up. We have got 3h to the 5 over the square root of h to the 6 plus 16. The question said, evaluate this when h equals 2. So if h equals 2, we've got dv by dh is 3 times 2 to the 5, 2, 8, 16, 32. 3 times 32 is going to be 96 over root of h to the 6, so that's root of 64 plus 16, which is 80. And we're going to give our answer, well, let's just give our answer in third form. Go straight to the calculator and cheat. Root 80 on the bottom, we've got 24 root 5. Okay, now it says the volume of the pile is increasing at a constant rate of 8 cubic meters per hour. Find the rate in meters per hour at which the height of the pile is increasing at the instant when h equals 2. Give your answer correct to 2 significant figures. So what we've been told here, we're given that the volume is increasing at a rate of 8 cubic meters per hour. Now that is volume, cubic meters per hour, so that's time. So that's dv by dt is 8. Let's just check that we're being consistent with our units here. This h was in meters and volume was in cubic meters, so we're working in meters and we're working in hours. Find the rate in meters per hour at which the height of the pile is increasing. So we need the rate that h is increasing with respect to t. So we've got connected rates of change. We're going to use the chain rule here. We've got v on the top twice. We've got t on the bottom twice. So fitting that together, dv by dt is dv by dh times dh by dt. dh by dt is the one that we need. So if we rearrange this, dh by dt is dv by dt over dv by dh. And actually this question was just asking us for a numerical value when h is equal to 2. So if we think what we've got, we have already that top one is 8, that bottom one is 24 root 5 over 5, and the question wanted it to 2 significant figures, I believe. So if we do 8 divided by that, we get, it's actually root 5 over 3, but to 2 significant figures, that is 0.75, and that would be meters per hour. We've done it to 2 significant figures. Okay, that was question 1. Question 2, another past exam question. We had a diagram showing a curve with equation x equals 37 plus 10y minus 2y squared, all to the power of a half, or square rooted. Find an expression for dx by dy in terms of y. So again, we're using the chain rule to sort this out. the big function is something to the power of a half. 37 plus 10y minus 2y squared. And then minus a half, multiplied by the inside function differentiated, which is going to be 10 minus 4y. And so it's not a very nice expression, but we've got, let's cancel out, we've got a half, multiply this, so 5 minus 2y, over the square root of 37 plus 10y minus 2y squared. That's our first bit. Hence find the equation of the tangent to the curve at the point 7, 3, giving your answer in the form y equals mx plus c. So at the point 7, 3, our value of we've got x, we've got y, we need to find the gradient. Now hang on, this is dx by dy, and the gradient is dy by dx. So dy by dx is the reciprocal of that. 5 minus 2y. And we're interested in what happens at this point, which is where x equals 7, but more importantly where y equals 3. So at y equals 3, we've got that dy by dx is the square root of 37 plus 30 minus 18 divided by 5 minus 6. In there we've got root 49, so 7 over minus 1. So we've got a gradient of negative 7. So our equation is going to be y minus y1. 3 is m x minus x1, giving us y is minus 7x. We've got plus 49, we're going to add another 3, plus 52. And there we go. On to the third question. It says find dy by dx if y equals x cubed e to the 2x. Just 2 marks for this one. We've just got product rule. Product of two functions, x cubed and e to the 2x. So dy by dx is the first times the derivative of the second. Differentiate e to the 2x, you get 2e to the 2x plus the second times the derivative of the first. And there is dy by dx. It might be nice to factorise this. We've got a common factor of x squared e to the 2x, and then we've got this 2x from there plus 3 from that bit. And there we go. That's maths.